S-Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Writing down the general solution for a second order partial differential equation is always fascinating because it consists of two parts, and when we know both the parts, then only we will be able to write down the general solution.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. I'm Dr. Neelam, and today we are going to discuss the general solution of second order linear partial differential equation. So we will start with the general solution. So general solution of second order linear partial differential equation, and we are using this abbreviation partial differential equation. We are using this abbreviation PDE for partial differential equation. So general solution, as we have already discussed for ordinary differential equation in our previous videos, general solution is consisting of two parts. So general solution is consisting of two parts. One is complementary function. Complementary function, and another part is particular integral. And when a solution is written as a combination of these two, that is called as the general solution. Since they both are the parts of solution, so they separately also they act as the solution of the given partial differential equation. But since complementary function and particular integral or particular solution, the complementary function is corresponding to the homogeneous part of the differential equation. Homogeneous part of the differential equation, and particular integral is corresponding to the right hand side, or we can say the non-homogeneous right hand side of the non-homogeneous partial differential equation. So when do we call equation as homogeneous and non-homogeneous? So since we are going to discuss only second order linear partial differential equation, so a general form can be written like this: uxy plus c uyy, because these three will be the second order partial derivative, where the second order partial derivative are involved in the second order partial differential equation. dux plus euy plus fu is equals to this free term g. So if this is, now if this g is equals to 0, if this g is equal to 0 and if this g is not equal to 0, of course this g can be function of the independent variables only, and it is clear from the subscript that independent variables have been taken as xy and unknown function has been taken as u. Therefore, this g can be function of x and y only. It cannot be function of u. So if g is 0, if g is not 0, if g is 0, this equation is called as homogeneous, and if g is not 0, it is called as non-homogeneous partial differential equation, of course. Now when it is homogeneous partial differential equation, then the general solution will be only the complementary function, because we cannot find out the particular integral for this, because particular integral is corresponding to this non-homogeneous part of the differential equation. So it is complementary function will be the general solution for this. While for non-homogeneous type of partial differential equation, the partial differential equation will be broken into two parts, the homogeneous part and the non-homogeneous part, and then the general solution will be consisting of both the parts, the complementary function and the particular integral. Therefore, we have to be very, very clear that homogeneous differential equation will be having only complementary function as the general solution, but if it is a non-homogeneous differential equation, it will be consisting of both the parts, complementary function and particular integral. In any case, the complementary function will be the solution corresponding to the homogeneous form of the given differential equation. Now we can say that if it is given homogeneous, then of course it is a homogeneous form. But if it is non-homogeneous partial differential equation, we need to write the homogeneous form of that partial differential equation, and then corresponding to that complementary function will be found out, and the right hand side, that is in this case if g is there, then that will be devoted to find out the particular integral. So that's what will be the strategy to write down the solution. Now we will start with the complementary function. So the first thing which is sure for finding out the complementary function, that if it is the given homogeneous partial differential equation, then of course the right hand side is 0, so this is the only form, and if it is non-homogeneous, then we need to write down the homogeneous form of the differential equation by taking the right hand side equal to 0. So in any case, for the complementary function, the differential equation will be written like this: AUXX plus BUXY plus CUYY plus DUX plus EUY plus FU is equals to 0. Even if G is not given as 0, we will be writing down this form of this. Now, we will rewrite the form by taking some abbreviations. Now, since we do not require these second order derivatives and first order derivative in this form, so let us say that the first order derivative of u with respect to x will be denoted by this operator d, and this partial derivative of u with respect to the second independent variable, that is y, has been denoted by this d dash. Clear? So this differential equation can be written as f d d dash is equals to 0. So the given differential equation will be in this form. So instead of writing down the second order derivative and first order derivative separately, we can write down the given differential equation in this form. So to find out the complementary function for this differential equation, we need to write down the auxiliary equation. How to write down the auxiliary equation for this? We will be replace this d with m and d dash with 1. Since it is a second order partial differential equation, therefore for sure it will be converted to a second order polynomial in m. That equation will be solved for the value of m. Now since it is a second order partial differential equation, so we will get a second order polynomial in m. Now for sure we will get two values of m. And let us say those two values are m1 and m2. Now, if these m1 and m2 are real and distinct, if these two values are real and distinct, and what could be another possibility? That they can be real but same value. We will take example for make it more clear. So if it is real and distinct, then the complementary function, this abbreviation we are using for complementary function, CF, so this will be written as C1, so F1 y plus m1x plus F2 y plus m2x. So this will be the complementary function if the two values of m are real but distinct. If they are real but same, then the complementary function will be written as F1 y plus m1x, and since we would like to find out the linearly independent solutions, therefore in the lines of the solution for the ordinary differential equation, we will be writing down the complementary function here, y plus into x. So, when both the values are real but same, so this x will be multiplied with this second function. So, that is how the complementary function will be used. We will take few examples to make it more clear. Let us say that find the solution, find the general solution for d square minus 2d d dash plus d square is equals to 0, and here the unknown function is u. So, this is d dash. Since we have already clarified that d stands for del u by del x, du is del u by del x, and d dash is being used for del by del y. So, for this we need to write down the auxiliary equation. For this we need to take only this part of the differential equation. So, d will be replaced with m and d dash will be replaced with 1. So, to convert this in form of auxiliary equation. So, auxiliary equation will be m square minus 2m plus 1 is equals to 0. Since we are considering for second order linear differential equation, therefore, always this polynomial will be in second order. So, it can be written as m minus 1 whole square. So, m is taking two values, 1 and 1, both are real but same. So, how to write down solution for this? So, complementary function will be written as f1 y plus x f2 y plus x, because the values of both m1 and m2 is 1, therefore y plus m1x and y plus m2x, and x will be multiplied because both the values are same. And since the given differential equation is the homogeneous only, therefore complementary function will be the general solution for such differential equation. So, that is how the complementary function will be written for this type of second order partial differential equation. So, we will take a short break here and we will discuss the particular integral in the second part of the video.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Now, welcome back to S. Chand Academy. So, in the second part of the video, we will discuss the particular integral to find for the second order linear partial differential equation. In the first part of the video, we have discussed how to write down the complementary function for a second order linear partial differential equation. So, for particular integral, as we have already discussed in the first part of the video, that the given differential equation should be of non-homogeneous type. So, let us say that the given differential equation is of this type, f d d dash is equals to some function xy, where d and d dash notation, d and d dash have already been made clear in the previous part of the video, where d stands for del by del x and d dash stands for del by del y. So, it is u here. The unknown function is u here. Now, the complementary function was corresponding to the part when this fxy was 0, and particular integral is when this fxy is there in the differential equation. Therefore, the particular integral will be written as 1 over f d d dash and this fxy. This will be called as the particular integral. Now, to find out the particular form for this particular integral, since it depends on these two type of, in these two parts, f d d dash and fxy. So, the techniques to find out the particular integral will also be divided into two sections, into two categories. One is for f d d dash, and another is for fxy. So if f dt dash, if we will be using the partial fraction to resolve it, so resolve by using partial fraction, and then the solution can be written. So for this, let us say that 1 over d minus md dash, and since it is a second order differential equation, so let us say that the one part of the partial fraction is this, and it is fxy. So solution for this will be written as integration of fx. Now, since we need to integrate it one time, therefore we need to convert this y in terms of x. So this y will be written as c minus mx and dx. So such a function will be written by using this relation, and then the integration can be taken for this, and then this can be found out as the particular integral. And one more part will also be there because it is a second order differential equation, so it will have two parts like this. So it is when it is depending upon this f dash d dash. Now second type is when this fxy can take some particular forms. So there are cases divided for that. So case number 1 is when it is of exponential type. When it is of exponential type, let us say fxy is taking this form e raised to the power ax plus by. So in that case, the particular integral will be found out by replacing this d with a and d dash with b, d with the coefficient of x and d dash with coefficient of y, and e raised to the power ax plus by, provided this should not be 0. FAB should not be 0. So this is case 1 for fxy. So if it is e raised to the power ax plus by, then the particular integral can be found out using this. Then second case is, case 2 is that if fxy is given in terms of sine or cos, and remember that if it is written in terms of sine and cos, then cosec and sec should not be used for this. So it is sine ax plus by, or we are taking cos ax plus by. Both the forms can be dealt in the similar manner, therefore we are taking it. So this is slash means or either this or this one. So if this fxy is given in this form, then pi can be written for this by replacing d square with minus a square. Please mention here, I would like to mention here that it is not minus a whole square, it is minus of a square. D dash square is minus of b square, then d dash is minus of ab. So it is not minus a into minus b, d dash will be replaced with minus ab, and that's how the fd d dash form can be replaced with a square, b square and ab by taking this substitutions, and then the pi can be written for that. Now if this fd d dash that is left hand side involves some terms like d by d dash, then they will be they can be written as d square by d dash, and d square can be written as minus a square, d dash can be written as minus ab, this gets cancelled, so it will be replaced with a by b form. So we should use them as it is. We should not take under root of this, that d will be replaced with under root of minus a square, because then it will become imaginary. And it cannot involve d raised to the power 3, 4 and 5, because we are considering second order linear partial differential equation. So pi will be written accordingly, and this by replacing this derivatives by the coefficient of x and y. In both the case, whenever it is either sine or cos, it will be written a similar thing. So it will be written as f of, and if we write down this f d dash as d square d dash and d dash square if the given differential equation is written in this form, where fxy is taking this particular form, say sin ax plus by, then it will be written as f of minus a square minus ab and minus b square sine of ax plus by. So this is our case 2. Then case 3 is that if it is of this form, fxy of this form, x raised to the power m and y raised to the power n. So where m and n are constants. So in that case, this pi f d dash x raised to the power m y raised to the power n, then this f d dash will be written, will be expanded in increasing powers of d or d dash, and then the integration can be taken place. When d is there in denominator, it represents the integration, and if d is there in numerator, it represents the differentiation. So that's how the pi particular integral, if the fxy falls under these 3 categories, is written like this. Now we can make it more clear by taking one example. So find general solution. Find general solution for del square z over del x square minus del square z over del x del y is equals to sine x minus 2y. As I'm mentioning again and again, that we should be very clear about our independent variables and our unknown function. In this question, our unknown function is z and our independent variables are x and y. So this can be written as d square minus d dash z is equals to sine x plus x minus 2y. So first, since we have been asked to find out the general solution, and since the right hand side is not 0, therefore the general solution will consist of both the parts, the complementary function and the particular integral. So we'll write down the complementary function by converting, by writing down the auxiliary equation for this. So auxiliary equation can be written like this. So it is m is equal to 0 and 1. Therefore CF will be written as, CF is written as f1 y, because m value of m1 is 0, and plus f2 y plus x. So this will be the complementary function. Now we need to write down the pi. So we'll find out the pi. So it is 1 over d square minus d dash sine x minus 2y. So if we compare it with the form of sine of ax plus by, so here a is 1 and b is minus 2. Therefore d square will be replaced with minus of a square, that is minus of 1. d dash will be replaced with minus of ab. So now it becomes plus because b is with minus sign. So it becomes 2. So pi will be replaced with minus 1 minus 2. So this becomes plus minus 2, and it is sine x minus 2y. So it becomes minus 1 over 3 sine of x minus 2y. So this becomes the pi of the given differential equation. Therefore the general solution will be written as the combination of by complementary function and the particular integral. So complementary function is f1y plus f2y plus x, and the particular integral, which is minus 1 over 3 sine of x minus 2y. So that's how the general solution for the given second order linear partial differential equation will be written, where this part is called as the complementary function, and this part is called as the particular integral. So that's how we have learned how to find out the solution for a second order linear partial differential equation, which will be consisting of two parts, complementary function and the particular integral. Complementary function will be corresponding to the homogeneous part of the differential equation, and particular integral will be corresponding to the right hand side of the non-homogeneous differential equation, where all the unknown function and its partial derivative will be written on the left side, and the functions of x and y only will be written on the right hand side. So, we have learned how to write down the complementary function and particular integral for a second order linear partial differential equation. Thank you very much.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.